How's it going, you guys? Welcome to another installment of Did You Know? Algebra 2 style. Alright, in this video we're going to be talking about something called completing the square. So essentially what completing the square does for us is it allows us to graph more easily. It also allows us to solve quadratics more easily, kind of like you saw in the last video, I believe, when we were starting to solve quadratics. So with completing the square, our goal is to create a perfect square factor. So like if I have x squared plus 8x plus 16, this is a perfect square because it factors as x plus 4 squared, right? If I were to factor this, it would be x plus 4 times x plus 4, such that 4 plus 4 is 8, and 4 times 4 is 16. So I have a perfect square factor because it's the same on both sides. If I were to draw a square, it would be x plus 4 on one side and x plus 4 on the other to find the area. That's why it's called a perfect square. So like in this one, if we're missing something to create a perfect square factor, we can add it to both sides of the equation to help us solve more easily. So what I mean by that is I look at this number right here. So I would like to factor this as x minus 4 squared, right? Because it's half of this number. A trick is the number that goes here is always half of the number in the middle, as long as we have 1x squared. If we have another number in front, something bad's going to happen. We're going to have to factor it out in order to actually complete the square with that. So in this case, I want to have it x minus 4 squared, but if I take negative 4 and I multiply it by itself, that would create 16, but I only have 12. So what I can do is if I add 4 to both sides of the equation, this becomes x squared minus 8x plus 16 equals 4. Now it will factor as x minus 4 squared equals 4, and then I can factor it or do whatever else I want with it. So in this first example, it's just going to be what number must we add in order to complete the square, and what equation is produced when we complete the square. All right, so here, half of this number is 3, and if I square it, it would be 9. So what I want to do is I want to add 9 to both sides of the equation. So that's the number that we would add, so that it would become x minus 3 squared equals 28. That would be the equation that we produce when we complete the square. So again, the trick is if I have ax squared plus bx plus c, to complete the square, I take as long as a is 1, I can take x plus b over 2 squared, and I add whatever number, so plus b over 2 squared to both sides of my equation. So I'm going to keep doing a few more of these, and you'll kind of see how it works as well. So with b down here, so right now I have, let's see, half of 10 is 5. 5 squared is 25. So I need this to be plus 25 or minus 25. It really makes no difference which way we go. But actually it can't be minus, because if this needs to be x plus 5 squared, right on that side, then in order to make this work, this would have to be a positive 25. So I'm sorry I said it doesn't matter, because it does. So in order to get a positive 25, I need to add, think about this, 34, right? So plus 34 plus 34, so that I get x plus 5 squared equals 58, and that will be the equation that I produce when I complete the square. I did that right? Yes. Sorry. A little bit off right now. All right. Moving on to part C. So notice I don't have an equal side to add to both sides, so I'm just going to do it to the one side. So this number here is 1. Half of 1 is a half, so I'm going to be creating x plus 1/2 squared. And when I take this 1/2 and I square it, right, 1/2 squared, that creates 1/2 times 1/2. Remember, you squared both numbers, so this would be like adding 1/4 to the equation. 1 times 1 over 2 times 2. So this would be the number we add. This would be the equation that is produced. All right, so part D, take half of 3, so I would have x minus 3 over 2 squared. It's really easy to produce the square. It's just a little bit more difficult to think what number we're adding to both sides. But if you take that number inside the b over 2 and you square it, that will give us 9 over 4, so I need to add 9 over 4 to that equation. So again, that's the number we add. This is the equation that is produced. All right, so next, to determine the solutions to the quadratic using complete square. So here's where actually we're going to be solving it, and you're going to see how much easier this makes it on us. Because here, this is my b term with the single x right there. It's 1x squared. So I need to factor this as x plus 3 squared. Now if I'm taking that 3 squared, that means I need to add 9 to both sides of the equation, such that now this is equal to 24. And then from this point, I can take the square root of both sides. Don't forget, whenever you take the square root, you need that plus or minus. So I have x plus 3 equals plus or minus the square root of 24. So now here's also where the square root of 24 can break down. So the square root of 24, the biggest thing I can pull, let's see, 6 and 4, I think that's all I can do. So this is the same thing as the square root of 4 times the square root of 6. I know the square root of 4 is 2, so this is 2 root 6. I wrote 2 twice. So now, and then the last thing I'm going to do to get the 3 or the x by itself is subtract 3 on both sides. So my solution is going to be negative 3 plus or minus the simplified square root, so 2 root 6. That's what they're looking for. Remember, that means both solutions are there. Negative 3 plus 2 root 6 and negative 3 minus 2 root 6. All right, moving on. So here, half of our b would be negative 7, so we have x minus 7 squared equals, so now if I take that negative 7 and I square it, it would be plus 49 on both sides. So 12 plus 49 would be 61. And then I can take the square root of both sides. Don't forget that plus or minus. Square root of 61 does not break down anymore. I believe that even is a prime number. And then just add the 7 to the other side. So you have x equals 7 plus or minus the square root of 61. That's it. All right, so here's one with fractions. Oh yeah, we love fractions. All right, but don't let them freak out. It's the same sort of stuff. So still, take that x plus 5 divided by 2. So now what number, in order to create this factor right here, I need to add to this side. So 5 squared is 25, 2 squared is 4. So I added 25 over 4 to both sides. So this equals now 25 plus 19 is 44. So 44 divided by 4, which is a nice number, it's 11. So now I have x plus 5 over 2 squared equals 11. Square root both sides. So now I have x plus 5 over 2 equals plus or minus the square root of 11. And then just subtract over that 5 over 2. So I'll have for my solutions x equals negative 5 over 2 plus or minus the square root of 11. It's ugly, but it's fine. There's nothing wrong with that. You can type it in your calculator and get the actual decimal solution to that too. Here, another nice one. So half of 4, my b term, so I have x minus 2 squared. So now negative 2 squared is 4, so that means I must have been able to add 4 to both sides to make that perfect square even exist. So now I have 17. Square root both sides, so x minus 2 equals plus or minus the square root of 17. Add the 2 to the other side, so x equals 2 plus or minus the square root of 17. There's my solution. All right, so like I was saying in the beginning, one thing that this does for us is it allows us to find our solutions. The other thing allows us to graph our quadratics much more easily. This is called vertex form. We looked at another one that was called standard form. So this is called vertex form, where a is just some number, hk is actually where our vertex is. The vertex of a parabola is just where the parabola is changing direction. So that is the vertex right there. Whether a is positive or negative will tell us whether the parabola is opening up or is opening down. All right, let's see what we got back here. All right, so determine the vertex of the following, which way the graph opens, and determine the maximum or minimum. So with this, our vertex, and notice in this last one, with our definition here, the vertex, when I pull it out, I had x minus h, but it came out as a positive h. And then I had plus k, and it came out plus k. So with this x, inside that parentheses, I'm going to switch the sign on that when I pull it out of the equation. So for my vertex in this one, if I switch the sign on the x, it's a positive 2 right now, so I'll pull it out as a negative 2. Outside is a negative 4, so I'll pull out a negative 4. So what that means is with my vertex, I have negative 2, negative 1, 2, 3, 4. That is the point where my parabola is changing directions. So now the other thing I was talking about is a positive or negative. Well, if I look in front of this term squared, that is a positive term right there. So since it's positive, all that means for us is this quadratic is going to open up like so, which means that if I follow this graph, it has a minimum value. So a minimum is just a low point, right? If I'm scooping out some ice cream, I go to the minimum I can in the bucket because I want the most ice cream because I'm a fatty, right? I go to the minimum of the bucket and then I scoop it out. So it has kind of a low point down there that I'm trying to scoop out. If I have a maximum, it is tossed up, it reaches a highest point, and then it falls back down. So maximum is going to be when our parabola is turned upside down, like so, where it goes up to a high point and then it falls back down to the ground. That's like anything that's tossed up in the air, except for rockets because they're projected into the air. But it goes up and it comes back down, it reaches a high point, and then it falls back to the ground, or wherever it goes. So with this one, determine the maximum or minimum, which way the graph opens. So this, I would say, opens up, and it has a minimum at negative 4. So notice I didn't put the point, I just put what the minimum value was. The x value of the minimum is our vertex, which is negative 2, but the minimum value is negative 4. It's what the output would be. So it's the y value of the minimum or the y value of the maximum. All right, moving on. So with this one, again, with the vertex, pull out the opposite with your x. So I have positive 3, and then same with the y, so positive 5. Now for the opening, notice this is a negative function this time. So when I go to my parabola, I am over 1, 2, 3, up 1, 2, 3, 4, 5. So I have a point here, and I will be opening down because it is a negative value. So when I have a negative x squared, it's going to open in the opposite direction. So this one opens down, and it has a max at the y value of my vertex because that's the highest point, so a y value of 5. All right. Again, don't forget to pause the video. You guys can go to Canvas as well. I'm uploading PDFs so you guys can follow along with the notes. But remember, I know I explain this stuff somewhat fast a little bit, but I only do that because you can rewind, rewatch, try the problems, see what you come up with on your own. As always, email me with any questions that you guys got. All right, so with the x, for my vertex, I have negative 1. With the y, I have negative 8. So remember, the x sign changes with the x, stays the same with the y values. So now with the openings, this x squared, this whole thing right there, that is a positive 3. So if it's a positive 3, 5, 6, 7, 8, my parabola is going to open up. I'm not worried too much about how it opens up right now. We'll talk about that later in this unit. But for now, all I need you to put for me is that this opens up, and it has a minimum, so it goes down to a low point at y equals negative 8. Okay, that's all we're talking about there. All right, for these next ones, determine vertex form of the equation. So all we're going to be doing, right, this was all vertex form. This was vertex form. So notice I have the x in the parentheses, right? It's a perfect square, right? So that's a perfect square. This was a perfect square. This was a perfect square. They may be multiplied by something on the outside, but they're still a perfect square term. So with this, so determining vertex form, I'm essentially trying to complete the square. That's what this is good for. So here, looking at my b, I need to have x minus 3 squared. Right? So if I need to have x minus 3 squared, That means I had to have a plus 9 right there in order to factor it that way. And I had to add 9 to the other side to make this equation true. So I have y plus 9 equals x minus 3 squared, and then I'm just going to copy that minus 9 over. So now last thing I'm going to do is just subtract 9, such that I have y equals x minus 3 squared minus 18, and there it is. That's my equation. Done. That's vertex form. All right, so we could pull out the vertex of 3, negative 18. We know it would have a minimum value because this is positive, so it's opening up. All right, moving on. So here, my factor should be x plus 6 squared. So that means I needed to have 6 squared, so I needed to add 36 over here and add 36 on that side. So y plus 36 equals, and then there is my factor of x plus 6 squared. So I still have that minus 8 on the outside. Subtract the 36 to both sides. So minus 36, so y equals x plus 6 squared minus 44. There it is in vertex form. All right, last one. We're almost there. You guys are doing good. Okay, so again, I need to have half of b squared, which would be negative 6. There's my perfect square. Negative 6 squared is positive 36. So all of that part right there is creating the perfect square. So I still have that plus 38 on the outside. Since I added 36 on this side, I need to do the same on that side. So y plus 36 equals all that junk. And then just subtract the 36 to the other side. So y equals x minus 6 squared plus 2. There we are in vertex form. All right, hopefully this video was helpful. Sorry it was a little bit long, but please, please, please let me know what questions I can answer for you guys as you go through this. All right, love y'all. See you soon.